Hello friends, I am Dr. N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology, and in this video we will focus more on entity declaration. How is the entity declaration? I will discuss what we have discussed in the last lecture. Just I will go back. We have discussed about the introduction and elements of the VHDL language. In introduction we have discussed about full form of the VHDL and what it can support, those kind of the things. Then how it can be used as a concurrent language, sequential language, then timing specifications, then simulation language, then it can be used as a test language, its design hierarchy, then design libraries and logic system, that is multi-valued logic system. Then we briefed about the basic building blocks, which is we have little discussed about the entity, how is the entity, how is the architecture, how is the configuration, and how is the package. And today I will start the discussion about the entity declaration part. In the entity declaration part, before going into that, we must know what are the legal identifiers. And here, the rules for legal identifier in the VHDL that I will discuss. What is the first point? Only letters, digits and underscores can be used to name any input port, output port, or maybe any legal identifier in the VHDL language. The first character must be the letter. First character must be the letter. The last character cannot be the underscore. At the same time, two underscores in the succession are not allowed in the legal identifier. As well as the reserved words of the VHDL cannot be used as an identifier. Which are the reserved words? Just I will show in the next slide the reserved word available in the VHDL language. VHDL language is case insensitive. Uppercase letter are equivalent to the lowercase letters. Some examples of the legal and illegal identifiers. I will discuss about this first identifier and I will check all these possibilities. It should have letter, digits and underscores. Here these are the letters, no digit is used and we have underscore. Fine. First character must be the letter. Yes, its first character is letter. This first character is a letter. The last character should not be the underscore. There is no underscore here. That's why fine. Two underscores in the succession are not allowed. Only one underscore we are using. That's why it is okay. Reserved word we are not using the reserved word. That's why this is legal identifier. In this case, the same thing. AB08B is the name. It follows these guidelines. First character is a letter. Last is not the underscore. We are not using the two underscores. We are not using the reserved word. That's why it is also valid identifier or legal identifier. In this case, first character is a letter, we are using single underscore and this number, that's why it is also valid. Last character should not be the underscore, it may be the letter or it may be the digit. In these cases, these are the letters and in this case it is also valid identifier. C underscore D underscore 07, it is also valid and valid identifier because it uses the combination of these three. First character is a letter, we are using the underscore and last character is not the underscore and we are not using the two underscore, that's why it is also legal identifier. Now look at, in this case, these are the examples of the illegal identifiers. This first character is a digit, this digit, numbers. What is the mandatory? The first character must be the letter A to Z. From A to Z, any A, B, C, D, any letter it should have. That's why it is invalid. Here signal #1. It is starting with the first character as a letter, but this hash, we cannot use hash. Only allowed character or special character is underscore. Only we can use the underscore. Other than underscore, we cannot use any other special character. That's why it is also invalid. Similarly, in this case, A underscore underscore 1023. We cannot use the two underscore in the succession. That's why this is also invalid identifier. And finally, about this, start with the letter underscore, clock and underscore. But here the last character should not be the underscore. We are using the last character as underscore. That's why it is also invalid legal identifier, or it is invalid identifier. These are the rules for defining the legal identifiers, and these are the reserved words used in the VHDL. ABS for absolute, access, after, alias, all, and, architecture, array, asset, attributes, and so on. And we should remember all these reserved words because we should not use this reserved word as an identifier. The identifier may be the name of the entity, may be name of the architecture, may be the name of the constant, may be the variable, or may be signal, whatever. That's why we should be aware of the reserved words used in the VHDL. Now in this case, I will start the discussion about the entity declaration. VHDL design description must include or must have only one entity. There may be the multiple architectures, but it should have only one entity. Entity declaration, it defines inputs and output ports of the system. Each port in the port list must be given in this way. It should have a name, that is identifier. It should have a data flow direction, that may be the input, may be output, or may be both. And it should have data type, maybe the real, maybe the integer, maybe the boolean, or maybe the std logic if we are using the 9-valued logic. And can be used as a component in other entities after being compiled into the library. Whenever it is compiled into the library, suppose we are using the AND gate. Whenever this AND gate is compiled into the library, then this AND gate can be used as a part of the bigger logic in the another module. Means two AND gates we can use in this particular way. This is one input, second input, maybe this is another two inputs, and these two inputs are combined together to form another input. Means in this particular way we can have system, and this may be the system, maybe this is A, maybe here it is B, this may be the C, this is D, and finally a system output is Y in this particular way. Is it right? Now what is the syntax? Syntax is the important. It should start with the reserved entity. This is reserved, followed by the name of the entity. Name of the entity is identifier defined by the user. Is again another reserved, followed by the port. Port is another reserved. Here it should be the port list. Port list means how many inputs we have, how many outputs we have, that kind of the things we have to define. Finally, end is another reserved, followed by the name of the entity. This is the syntax for entity declaration. I will take one example, and through this example we will try to understand how to declare the entity. In this case, this is the IC, and for this particular IC we are defining the entity declaration part. This is ground pin and this is VDD pin. These two pins are functioning as a power source, and these are not the inputs of the system. And here this entity must include only the inputs. How it is? This A1, B1, these are the inputs. Then A2, B2, these are the inputs. Then A3, B3, these are the inputs. And A4 and B4, these are the inputs. We can define all inputs in single line, or we can show in this way also. This is A1, B1. These are the two identifiers. A2, B2. A3, B3, A4, B4. We have to be careful about whenever we are using these input ports or input port names, to be exact, identifiers. These should be the legal identifiers. At the same time, while defining this entity followed by the name of the entity, this is the name of the entity, it should follow the rules of the legal identifier. Now here in this case, this is a valid identifier, then A1, B1, A2. Otherwise we can use A1, B1, A2, B2, and finally we can write in std underscore. This in stands for its direction, that is input, and this std logic stands for its data type. Here we can use a bit also, but if we are using the bit here, it will support only for the two logic values, that is 0 and 1. And whenever we are using the std underscore logic here, it will support for non-values logic, which we have discussed in the previous lectures. These are the inputs defined in the system. We can use the 4 lines or we can use the 8 lines, 1, 2, 3, 4, 5, 6, 7, 8, or we can define in the single line also, that is fine. At the same time, we have the 4 outputs. This is one output, this is the second output, this is the third output, and this is the fourth output. With Q1, Q2, Q3, Q4, colon, its data direction is out and its data type is std underscore logic, followed by the bracket and followed by the semicolon. That is the standard way. And finally, it should end with name of the entity. Whatever we have given the name of this entity, same should be here. Here is another example of the entity declaration. What is the standard format of the entity declaration? I will go back. I will repeat once again. It is entity followed by the name of the entity is, then port, and then port list, and then end, and finally the name of the entity. Whatever we have here, the same should be here. I will start the discussion for the second example. In this case, this is reserved word followed by the name of the entity. Here, name of the entity which I have given is ALU, that is arithmetic logic unit. Followed by the port, which is reserved word, and then we will define the port list. Maybe the input or maybe output. We can define A and B. This is 0 to 7, 8 digit. This is 8 digit. It can be defined in the single line. Selection 0 to 5, 6 digits. This data size and this data bus width is not the same. That's why we have to use another width. Selection, its direction is in std underscore logic underscore vector, means it is a bus 5 down to 0. And finally we have this output. S is equal to, this S is equal to 7 down to 0. This is 7 down to 0. This is S, and I have not defined this O, or you can define the O here. This O colon std underscore logic, that's it, and the end ALU, that is the declaration of the entity. This is the way of entity declaration. I will end this particular lecture here, and maybe in the next lecture I will discuss about the architecture. Thank you.